So if we have an element of P1 over our global field and a polynomial over Kx, we can homogenize and we homogenize so that we can plug gamma in. But the homogenization has the same coefficients, so reasoning about the homogenization should give us the correct result for our original polynomial. And then I'm going to use the same notation as Silverman to define delta sub nu of m, which is equal to m if nu is Archimedean, and 1 if nu is non-Archimedean. So then I want to call this the magnitude of f upper star evaluated at gamma is equal to, let's see, so we have the sum from I equals 0 to d of the coefficients of f times alpha to the d minus I beta to the I and this is the number of terms less than or equal to the number of terms, which is our delta v of d plus 1. Wait a minute, something feels off. Okay, so I just double checked my work, and this is correct. This is delta v of the number of terms times the magnitude of each of the terms, or sorry, the max over the magnitude. This is the triangle inequality in both the non-Archimedean or Archimedean place. That's why we define the delta nu to be what it is. Okay, so further, we can see that while the max function is not multiplicative, we can get a further inequality by taking the max of each of the things separately. So we get delta nu times d plus 1 times the max over the AI, the magnitudes of the AI, and then times the max of each of the variables. I don't know what else to call them. Oops. Yeah, raised to the d power. Same thing. And so we could see that this is equal to v of d plus 1. So this here is the magnitude of our original function, our original polynomial at our place, since the coefficients of the homogeneous polynomial are the same, times the magnitude of our point gamma raised to the d power at b. So hold on 1 second, my animals are fighting. Okay, so we can extend this reasoning to rational functions. So for phi equal to f over g, I'm going to use this notation, which I think I got it from Silverman. I don't see it in your paper, but if we're looking at the magnitude of phi of gamma, which is the magnitude of f of gamma and g of gamma, with the same reasoning, we can just replace the magnitude of f here with, we take the max over all possible coefficients of f and g. So it looks like this, d plus 1 max f g, oops, times, ran out of room, gamma of v, which is just a shorthand for, we can replace that max with the magnitude of phi. So from here, we can talk about the heights. And there's just a couple of things here that I'm not certain about. Okay, so we have our height of phi of gamma, which we can write as, by definition, with the product over all places on our field, the max of 1 and the magnitude of phi of gamma at our place. So for each one of these that is greater than 1, we can kind of replace it with using this inequality up here. So we can rewrite this as v in our places, or new in our places, max of 1 delta nu delta plus 1 times phi times gamma. And so this delta is always greater than or equal to 1, no matter, or by definition, so we can pull it out of the max function. And then here, what I want to do is pull out the magnitude of phi from the max function, but I don't think I can do that necessarily, so I'm wondering, because doing that gives me what I want, but I don't feel like it's necessarily always greater than 1. At least 1, unless we're talking about monic rational functions, monic polynomials, monic f and g. I don't know. And then so then we continue to have our max. So let's pretend like we have this for a moment. And we have our, this should be to the d power, v to the d. And so then, so the product over all places of delta v of d plus 1, this is only going to be, it's either going to be d plus 1 for the non-Archimedean place, for the Archimedean places, or it's going to be 1 for the non-Archimedean places. So this is just, d plus 1 to the Archimedean places of k. And then for the second part, the magnitude of phi is our definition for the height of phi. And this is the last piece is our definition for the height of gamma to the d. Gamma to the d. And we can pull out the d because everything here is multiplied together. So it would be the same in either case. Yeah, so that gives me essentially what I want, as long as I can pull this out. That gives me hk phi of gamma is less than or equal to d plus 1. Hold on, sorry. Okay. D plus 1 to the Archimedean places, which is the degree of phi, plus 1 to the Archimedean places of k times the height of phi times the height of gamma to the d. The one thing I don't have is, you call this b sub fg k, I believe it is. And you have this to be, maybe it's not k. Let me double check. Oh, I just have the order wrong, but yeah, it is b, g, and f, g, and k. And you have this equal to the max of 2 and this quantity that I have here. And I'm not sure where the 2 comes from. But yeah, that's what I have so far. I have